PoE and PoL are the next parameters we're going to discuss. PoE stands for Power over Ethernet. It has the ability to do exactly what it says, carry data and power over Ethernet to the network devices. In this schematic over here, if you're installing a camera, there's an Ethernet cable that carries network data, but then you also have to plug in the power cable. So there's two cables that you have to support. But with PoE, all you have to do is run one Ethernet cable from your switch to the camera, and that cable now supports network data and electrical power. What are the benefits of it? It saves you a lot of money because now you don't have to run that power cable. Based on the installation of the cameras, you have to have power available there. But with PoE, that is not the case anymore, so you save money. Another thing is flexibility and scalability. If you're using a non-PoE method, you're limited to where the power outlet is for the camera. But if you eliminate that and now use PoE, you can install your cameras much further away and not necessarily dependent on where your power outlets are installed. And there's different standards for PoE. There's IEEE 802.AF, 802.3 AT, and there's 802.3 BT Type 3. Different standards, it's just networking lingo, but what it really means is how much wattage is available at the end location where the device needs to be powered. How do these play a role? Let me give you an example. So the switch that is powering that end device, it needs to be able to support the enough wattage that the device needs. For example, if I'm taking this switch here and connecting it to this camera, the type of question I would ask my customer is, how much wattage does that camera need so my switch can support it? And they may say it needs 20 watts, 30 watts, 40 watts. At that point, you have to see if our switches support that. Here's an application. PoL is the very similar idea such as PoE, but now it's not the Ethernet cable, but now it's using that same telephone cable that we talked about, a simple twisted pair cable, and it does the same exact thing, data and power. In this application, these units are used in pairs. They're PoL units, ED353AT and ED353AR, and they're utilized and they're connected together by a copper cable, which transmit data and power. The left-hand side, the transmitter end is connected to a switch via Ethernet cable, and on the right-hand side, the Ethernet cable is connected to one of the network devices, such as IP camera, VoIP phone, or wireless AP. And you could send power up to 1.2 kilometers over single pair of copper wire, or 1.6 kilometers for a coax cable. Here's a really good table that summarizes the data rate and the power available based on the distances. There's a general trend. As the distances increase, the data rates lowers, as well as the PoE output. And the reason for that is because you're losing a little bit of data and a little bit of power as the distance increases, which makes sense because the farther you go, the less distance and data is available.